or the blockchain. So today's topic is cryptography and blockchain securing the data, right? So welcome back. In this episode, we'll be diving deep into the fascinating world of crypto and its role in securing data in the digital age, which is an essential component of blockchain technology and providing the necessary tools to ensure the privacy, authenticity, and integrity of the transaction. So now let's get into what is the cryptographic algorithm. To begin with, let's talk about what is the algorithms used in blockchains such as SHA-256, etc., etc. These algorithms play a crucial role in encrypting data, making it unreadable to unauthorized parties by employing strong cryptographic algorithms, right? So let me share the screen. Give me a few seconds. Here you go with the screen. Yes, so that it becomes a bit more clearer, right? So this is how the cryptographic algorithm looks. When you give the plain text and you have the secret key, the same key is used and it is decrypted. So this is the ciphertext. No one can understand what is there, and then again it goes into the plain text when it is decrypted. So this is how the crypto algorithm works, right? I hope you got some insights into it. And now let's move on to the cryptographic keys and digital signatures in a bit details. So cryptographic keys are mathematical values used to encrypt the data and decrypt the data. In blockchain, public and private key pairs are generated where the public key is used for encryption and private key is used for decryption. Digital signatures, on other hand, provide way to verify the authenticity of the data, and they are created. So this is how the another version of crypto algorithm and another version of how private and public key is used, right? You can see this. And then we have the hashing algorithm also. So this is how the keys and hashing algorithm is used. They are created using private and public key and can be verified using the corresponding public key itself, right? So next we will explore what is symmetric and asymmetric encryption. For that, let me just share another screen. So we have seen what is how the key is used. First, we just saw how the key is used, and what is public key, what is private key. Now we are diving deeper into what is symmetric encryption and asymmetric encryption, right? So symmetric encryption uses single key for both, right? Both ways, right? Encryption and decryption, and making it efficient for bulk encryption. On the other hand, asymmetric encryption uses a pair of keys, a public key for encryption and private key for decryption. Asymmetric encryption is commonly used for secure key exchange and digital signature in the blockchain network. Right. Next, let us look at secure key management. So for that also I have another visual. So this may be very technical, and I'll still try to explain it in simple terms. So the secure key management is of utmost important in maintaining the data security in blockchain. As cryptographic keys are the backbone of security, it's crucial to protect them from unauthorized access. So proper key management practice include secure storage, include key rotation and access control, and are essential to prevent key compromise and ensure the integrity of blockchain data. So this is how the key is to protect the key. Again, it goes into another key, right? And then you can use it as you want. Now, in the next frame, we are going to see what are the privacy enhancing technologies. This is the final frame of today's discussion, let's discuss what is privacy enhancing technology in context of blockchain. One such technology is zero knowledge proofs, which allows participants to prove the validity of statement without revealing the underlying data, right? So zero knowledge proof can enable privacy preserving transaction while maintaining the security and integrity. So what does it mean that zero knowledge proof, which is allowing participant to prove the validity of statement. So that is, they will be giving the proof that yeah, this is the valid data without actually revealing the underlying data. So this is known as zero knowledge proof and can enable privacy preserving transactions. So we are preserving the data, but we are still saying that the data is valid, right? So this is how it looks. There are three senders, and then send the data into the cloud with the recipient keys. The data is here. Encrypted data is processed on the cloud server, and it is a processed data. The recipient decrypts the encrypted data using recipient key. So the data is not actually revealed, but at the end, when the final recipient uses the recipient key, he can see what is in the data, right? So that's it for today, and so let's summarize what we learned today. So that wraps up this discussion. Today we explored the use of cryptographic algorithms, importance of cryptographic keys and digital signature, symmetric and asymmetric encryption, secure key management, how you secure your key, privacy enhancing technologies like zero knowledge proofs, and understanding cryptography is vital for grasping the security foundations. So I know it may be a bit technical, but just take a look at this video a couple of more times. Since it's a very short time, I don't want to keep the videos too big, and I cannot explain it beyond certain point. Otherwise, I can even take a session of say half an hour or 45 minutes for this. But I hope you got something, and maybe you can also do your own research based on what we discuss. And don't forget to like and share and subscribe the channel and share it with others. See you in the next video. Bye bye. Thank you. Take care. See you tomorrow. Bye.